go ahead and take a look at the last example in section 4.3. We want to find the relative extrema of f of x equals x to the fourth plus 1 divided by x squared. One of the things we should always take note of when working with any function is its domain, and unlike the last few examples, this function does not have the domain all real numbers. In particular, whenever the denominator is equal to 0, which occurs when x equals to 0, f of x is going to be undefined. And that's one of the numbers that we're going to need to use later on when we do our interval test chart. Let's go ahead and find our critical numbers. So we're going to go ahead and take the derivative, which would involve using the quotient rule. F prime of x is going to be equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. We want to simplify this. We have 4x to the fifth minus 2x to the fifth minus 2x all divided by x to the fourth. This is equal to 2x to the fifth minus 2x all divided by x to the fourth. And we can do a little bit more. Let's factor this. The numerator has a common factor of 2x we can pull out. We have an x to the fourth minus 1 all divided by x to the fourth. And now we get a little bit of cancellation here. We can cancel one of those powers of x. And so a nice expression we should be able to use for the derivative that's simplified is that f prime is going to be equal to 2 times x to the fourth minus 1 all divided by x cubed. So standard derivative is something we did a lot in the last unit. So f prime is 2 times x to the fourth minus 1 all divided by x cubed. Let's now go ahead and find our critical numbers. We first want to solve for where f prime of x is equal to 0. So we're going to take this equation, set it equal to 0 and solve. To start, we want to clear fractions by multiplying both sides by x cubed. That'll leave us with 2 times x to the fourth minus 1 equals to 0. We can divide both sides by 2. We get x to the fourth minus 1 equals to 0. And now what we have is a polynomial equation. And one of the best ways when you're able to solve these is to try and factor it. X to the fourth minus 1 is actually a difference of squares. This would factor as x squared minus 1 times x squared plus 1 equals to 0. This first part is another difference of squares. This factors as x minus 1 times x plus 1. And one of the things that you might recall is that the second piece, which is a sum of squares do not factor over the real numbers. So that's just going to stay as it is. We now are going to take and set each factor equal to 0 individually. X minus 1 equals to 0, x plus 1 equals to 0, and then x squared plus 1 equals to 0. Add 1 to both sides, we get x equals to 1. Subtract 1 from both sides, we get x equals to negative 1. And then for this last piece, you would have x squared equals to negative 1, which would produce two imaginary solutions, x equals plus or minus I. We're only interested in real valued solutions here, so essentially we don't get anything else from that last term. So that's two types of critical numbers. The only place where f prime would be undefined would be when x cubed equals to 0, taking the cube root of both sides, and we get x equals to 0. This value we've seen before. Remember, this is not in the domain of the function f, so this actually isn't going to be a point on the graph, but it will nonetheless be a number we have to use when we now go to our sign chart. So altogether we have three values we need to use. We have 0, 1, and -1. So we have -1, we have 0, which I'm going to leave as an open circle on the number line because it's not a part of the domain, and then we have +1. Those three values will subdivide the number line up into 4 regions. And we're now going to go ahead and do the sign chart for these. In region 1, a good test point might be, let's say, x equals -2. We're going to take that value and plug it into the derivative. F prime of -2, this would be equal to 2 times -2 to the 4th minus 1, all divided by -2 cubed. This is going to be 2 times -2 to the 4th is 16. 16 minus 1 is 15. In the denominator, we get -2 cubed, which would be -8. And so altogether, this is going to end up giving us the value -15/4, which is less than 0. Again, the value itself is irrelevant. We're just concerned with the sign of it. But certainly one of the things that we notice is that in quadrant 1, f prime is going to be less than 0. So in that region, the function is decreasing. Let's take a look and see what's going to happen in region 2. Might try a test point of, let's say, like x equals -1/2. F prime of -1/2. This is going to be equal to 2 times -1/2 to the 4th minus 1 divided by -1/2 cubed. This is going to be equal to 2 times -1/2 to the 4th would be +1/16. +1/16 minus 1 would be a -15/16. In the denominator, we get -1/2 to the 3rd power, would end up giving us a -1/8. And altogether, if we work this out, I believe it's going to be +15, which is greater than 0. So in region 2, we see that the derivative is positive, which means that the function is increasing. I'll let it up to all of you to kind of go ahead and check these next ones on your own. But if I were to do a test point for region 3, a good candidate might be x equals to 2/2. You can kind of cheat a little bit too. If you look at this derivative would actually be an odd function. So the value of f at +1/2 was actually going to end up being the value of the negative of the value of f at -1/2. And so what you should find out is it's going to be negative here. F prime of 1/2 should be negative, which means that the function is going to be decreasing. And in quadrant 4, a good test point might be using, let's say, x equals to 2. If you check f prime of 2, that should be greater than 0. So it's going to be increasing in region 4. Now with all of this information, we can go ahead and classify our critical numbers. At x equals to -1, it changes from decreasing to increasing. So that's going to produce a relative min. So at x equals to -1, we're going to have a relative min. The value of that relative min is f of -1 equals, it's -1 to the 4th plus 1 divided by -1 squared, which is going to be positive 2. So we have a relative min of 2 at x equals to -1. You have to be very careful. A lot of students, if you're not paying close attention to this, some students might mistakenly believe that because there's a sign change in the derivative from positive to negative, that there's going to be a relative max at 0. But remember, 0 was not a point in the domain of f. So there's no value there, so it cannot be an extrema. However, our other critical number was x equals to +1. And at x equals to +1, we do have another change in the sign of the derivative. At x equals to 1, it changes from decreasing to increasing, which means that that too will be a relative minimum. So at x equals to 1, we have another relative minimum whose value is f of 1, which is 1 to the 4th plus 1 divided by 1 squared, which should also be 2.